All right, everybody, it is time for Dickey's Deep Thoughts. And today, Jim is explaining why those 10-day and even 45-day forecasts aren't always accurate. Jim, we see these on a lot of stations across the country, a lot of stations here in town. Greg, what are you doing over there?
Nothing. I was just going to.
You're just hanging out?
In my box of approval.
We were waiting for you to sing, but you didn't.
No, I'm not going to sing.
All right. All right. Back to subject at hand. A lot of us want to know an extended forecast, of course, but some of those they're long shots.
Yeah, it's a big trend that's sort of, I think, taken over the country, and this all goes back to how we put forecasts together. And a big tool we use is forecast models, like this one. This is our storm tracker model. I show this to you almost every morning. So what happens here, we take what's actually going on, the model ingests that, and it uses math and science to sort of predict what happens going forward, and it takes it all the way out. This model actually goes out about 2.5 days.
Okay.
Some go as far as 10 days. Some go further than that. But the problem is, as you get further out in time, the error gets exponentially worse with a model. And this was actually put out by the NWS in Kansas City. I think it's a great sort of visual way to think about it. I know these words are small, you probably can't read them, but think of it like a Plinko game. So you have your initial conditions, that's when you drop the ball in, and then at the bottom of the Plinko game, all the different solutions. Problem is, if it starts to take a bad path in the beginning, well, it's going to wildly sway the path at the end. So yeah, those errors start to compound. Let's go ahead and take this to the wall, because I actually did a little bit of an experiment here.
Okay.
I looked at forecasts from the European model, which is generally thought of as the best forecast model. And I took 10 different days and 10 days of temperature forecasts, high and low temperatures. I found the error versus what actually happened, and then I averaged out those errors for each and every day that I found those numbers. And look at how that error changed. So through about 5 days, temperature errors 2 to 3 degrees, that's not too bad. Once you get past day 6, those errors really ramp up. To sort of sum that up for you, we're talking again from day 1 through day 5, errors only about 2.5 degrees. Once you get 6, 7, 8, 9, 10 days, 6.3 degrees. Guys, the highest error I had was actually 27 degrees for one of the low temperatures on day 8. So that's the key here. As you go forward in time, the error on these models is going to really start to increase. So those forecasts you see, the value really starts to fall off too. Now, there is such a thing as long-range forecasting. There's some value to that, but it's more of when you start to look at patterns. Is it going to be warmer than average, colder than average? Is it going to be rainier than average, drier than average, or trends going forward? But actually a daily temperature forecast, high, low, rain, once you start to get in 6, 7, 8, 9, 10 days, not much value left.
So that's why you don't do that 10-day forecast.
That's why we stick to 7.
And you're the most accurate forecast here in Southwest Florida as well. So it's interesting. And you know what's risky about that? In this vacation land, so many people they want to plan 2 weekends out or whatever for their family and friends coming in town, and it might not be right.
Right. We can start to get an idea as we go forward. Like, say, perhaps I'm already looking forward to Christmas because I'm going to be traveling back north. So I'm thinking, oh, what's going to happen? I take those models out. But I know when I look at something 10 days from now, there's a very good chance it's going to change wildly. So we track trends and things like that. But an actual forecast, not much value in it that far out.
There you go. Stick to the 7.
Yep.